Hi everyone, welcome to our tutorial lecture on binary logic and binary circuits. And you should have already watched the lecture on this material first. And if you have, you'll see that I cover a lot of material there. And you might be wondering, well, what kind of questions could I ask and what are you responsible for? And how do I solve those problems? And that's what I'm going to be doing in this tutorial. Okay, so basically there are two types of questions that I want you to be able to answer. One of them are binary logic questions and the other one is binary circuit questions. Okay, for the binary logic, it's sufficient to be able to resolve, just evaluate, expressions like this, like 1 or 0, 0 or 1, and so on. Okay, and so remember we studied four logical operators: and, or, exclusive or, and not. Okay, and, or, and exclusive or, they'll take two binary numbers and combine them into one. Not will take just one binary number and flip its value. Okay, so let's just start with this first question here. So it says evaluate the following. Okay, and so if you do 1 or 0, that's going to equal something, and I expect you to be able to figure out what that is. Now, let me remind you how OR logic works. OR logic says if at least one of the two numbers is a 1, the answer is a 1. Otherwise, it's a 0. Okay, once again, with OR logic, all right, like we have here, OR, if one of the two numbers is a 1, or if both of them are a 1, the answer is 1. Okay, only if both numbers are 0 do you get 0. Okay, so here 1 or 0 is going to equal 1 because at least one of the numbers is a 1. Okay, and here 0 or 1, what's that going to equal? That will also equal 1. Okay, with these logical operators like OR, exclusive OR, and the order doesn't matter. So if you do 1 or 0, or you do 0 or 1, you get the exact same answer for all of them, not just for OR. Okay, then 1 or 1, well, they're both 1, and so that's going to equal 1. Okay, and maybe I'll just add one more here to complete it. So 0 or 0, there we go, 0 or 0 is going to equal, well, only if they're both 0 do you get 0. Oh geez, there we go. Okay, 0 or 0 equals 0. All right, now how does the exclusive OR work? The exclusive OR works the same as the OR does, but if they're both 1, it's equal to 0. Okay, so with OR, if they're both 1, it's equal to 1, but with exclusive OR, if they're both 1, it's equal to 0. Okay, so you do 0 exclusive OR 0 here, and that's the same as this one. Okay, and so 0 exclusive OR 0 is equal to 0. All right, 1 exclusive OR 1, you think, well, is that like 1 or 1? Nope, because 1 or 1, this is the only place where they differ. 1 or 1 is equal to 1, whereas 1 exclusive OR 1 is equal to 0. Okay, maybe I'll just add in another one here. 1 exclusive OR 0 is equal to, well, if at least one of the two is a 1, it's a 1, because it's just exclusive OR is just like an OR in that respect. This is the only place where it differs. That one will differ from that one right there. Okay, otherwise they're the same. Okay, what about not 0? Well, not 0, not all it does is it inverts the value, so not 0 is going to equal 1 like that. Okay, and finally, let's practice some AND logic, and with AND, they must both be 1 in order to get a 1. Otherwise, it's 0. Even if one of them is a 1 and the other one isn't, it's not sufficient for just one of them. They must both be a 1. Okay, and so here, if you do 0 and 1, 0 and 1 is going to equal 0. If this were an OR, it would have equaled 1, but it's an AND. And AND says, nope, they must both be 1s. Are they both 1s? Nope. So then it's a 0. And again, the order doesn't matter, so 1 and 0 is equal to 0 like that. Only if they're both 1s, you get 1 and 1 equals 1 like that. Okay, so I would have questions like this and mix them up. Now, your test and your assignments are multiple choice. So I actually have a little bit of a variation on this. The way I ask the questions is I say basically which of the following is incorrect. So I'll give you 5 possibilities, and you have to go through all 5 possibilities and figure out which one is incorrect. Okay, so which of the following 5 is going to be incorrect? So you take a look at the first one, 0 exclusive OR 0. Is that correct? It is. Okay, 0 exclusive OR 0 is just like 0 or 0, and neither of them are 1, so you get a 0. Okay, so that one is correct. Okay, what about 1 or 1? Well, 1 or 1 equals 1. That one is also correct. Okay, And what about 0 and a 0 equals 0? Is that one correct? It is. Okay. And over here, not 1 is equal to 0. That one is also correct. This is incorrect because 0 or 0 should equal 0, but in fact I have 1. And so to answer this question, you would pick E. Okay, so E is the correct choice. Okay, so why do I do it that way? Well, because this way you have to go, you have to search through a lot of the right ones, and each one you have to work out in your mind, is that one correct, is that one correct? Okay, and then you have to pick out the one that is incorrect. Okay, it makes you do a little bit more work searching for the one that's incorrect. Okay, so that's the kind of question that you would get for logic. And the logic tables are pretty easy, so these problems you should just be able to get the full marks on them, because there should be nothing that's very tricky there. Okay, now I'm also going to be asking you to do some logic circuits, and you could do them using the website logic.ly/demo. Okay, and so let's do this first question here, which is using logic.ly/demo. Let's demonstrate how the AND, the OR, the exclusive OR, and the Noc Gate work, or how that logic works. Okay, so basically all the logic that you've learned should have an equivalent in a gate, and so I'm just going to demonstrate that. Now that's a bit of an easy question, because all you have to do is just use a isolated gate, but let's do it together anyhow. Okay, so I'm going to switch here to logic.ly. Actually, that's for our second problem. Right there, like that. Okay, and the question was demonstrate AND logic using logic.ly, okay, the website. All right, and so over here you have to identify which is the AND gate. Okay, now they're labeled, so that's pretty easy to do. You see here how it says the AND gate. Okay, but remember that the AND gate looks like that, kind of like a bullet like that, and the two leads on the left hand side, those are the inputs, and the single lead on the right hand side, that's the output. Okay, for inputs what you use is a toggle switch. Well, I guess you need two toggle switches, one there and one there. And then for the output, you need a light bulb like that. Okay, and then you have to join it up. So now what I'm doing is I'm putting my mouse over top of the little lead here from the switch and dragging it to the one lead on the AND gate. And then for the other switch, I drag it to the other lead. Okay, and then I have to attach the output from the AND gate. So I'm clicking and dragging to the light bulb, and there it is, it's attached. Okay, now the question said to demonstrate AND logic, and the way AND logic works is only if both switches are on is that light bulb going to be on. Okay, otherwise it's off. Well, right now both light switches are off. Okay, and I could turn on one, so you could see there that I turned on the bottom one because it's blue, and the light bulb is still off. Okay, I can turn on the top one with the bottom one off, and the light bulb is still off, but only when I turn on both does the light bulb turn on. Okay, so if both switches are off here, you can see here both switches are off, the light bulb is off. If the top switch is on, the bottom switch is off, the light bulb is off. Top switch is off, bottom switch is on, light bulb is off. Only when both switches are on is the light bulb on. Or another way to think about it is if there's at least one switch which is off, the light bulb is off. Okay, so there you go. At least one light switch is off, light bulb is off. At least one light switch is off. They're actually both off, but at least one is off, so the light bulb is off. Okay, and it doesn't matter which way you do it, as long as there's one light switch off, the light bulb is off. Only when both are on is the light bulb on. Okay, there we go. We've demonstrated AND logic. Okay, let's now look at OR logic, and here's the OR gate. It kind of looks like that arrowhead, like that. And once again, we're going to need an output. And so you just click here, so you see the toggle switch, that's an input. We're just going to grab that toggle switch, click and drag it to there, and then also click and drag it to there like that, and then we just join by clicking and dragging like that. Okay, and I'm going to spread it out a little bit, clicking and dragging like that. Okay, so this one now is the OR gate, and the way the OR gate works is only when they're both off is the light bulb off. As soon as I flip one switch, either one, the light bulb will come on. Okay, so it doesn't matter that one light switch is off. It's sufficient. It's enough for one light switch to be on for the light bulb to be on. Okay, whether it's the top one or the bottom one, doesn't matter, or even if it's both of them. Okay, so there we go. That's OR logic. Let's now demonstrate exclusive OR logic. So this is the exclusive OR. Here, I'll put it under the OR. And you could see that they look the same, but the exclusive OR has that extra little fin there, like that. And let's demonstrate how it works. All right, like this. And attach that, like that. And then we need a light bulb there, like that. Okay, and we can actually compare the OR and the exclusive OR. All right, so when both switches are off, both either for the OR or the exclusive OR, the light bulb is off. Okay, when I turn on the top switch for the OR, the light bulb turns on. Sorry, even though the bottom switch is off. Okay, it's sufficient for just one switch to be on. And same thing with the exclusive OR. Okay. And it doesn't matter if it's the top switch or the bottom switch which is on. Okay, so again, there one light switch is on, one off, and the light bulb is on. And for the OR, if both of them are on, the light bulb stays on. But with the exclusive OR, if they're both on, the light bulb is off. Okay, so that's where the difference occurs, right there. Okay, when both switches are off. Otherwise, any other configuration, on, off, the light bulb is on. Both off, both have the light bulb off. Okay, off, on, light bulb is on. So I went through all four possibilities. They agree in every respect except when both light switches are on. Okay, and that's basically, the idea that one exclusive OR 1 is equal to 0. Okay, that's what this bottom gate is saying. Whereas the top one says one exclusive OR 1 is 1. Okay, remember on is 1 and off is 0. Okay, and then finally, let's take a look at the Noc Gate, how that works. So here's a Noc Gate, and it has only one input. Okay, so there's my one input, and it has only one output. Okay, let's join up the components. So I'm clicking and dragging. You see, light switch is off, the light is on. Light switch is on, the light is off. All right, so we went through all four possibilities there. Okay, now this question is a little bit ambiguous the way I've written it. Like you say, well, what do you mean by demonstrate it? But since we did it together, that's okay. The next two questions are more similar to what I would give you on a test or on the assignment. Okay, so the next question says, using logic.ly demo, complete the following table for circuit A. Okay, now I'd have to give you a diagram for circuit A. Oh, sorry, you can't see the question. Hold on here. Okay, so using logic.ly demo, complete the following table for circuit A. You say, where's circuit A? I'd have to give you a diagram for circuit A. Okay, so that diagram for circuit A is right here. Okay, hold on, I'll get to it. There it is. Okay, so that's circuit A. Okay, now I give you that diagram, and during a test of the assignment, feel free to use logic.ly, the site, to build the circuit. So let me just show you how to build that circuit, and then we'll answer the question. So there's a lot more going on with this one, and this one actually has 3 gates. Okay, there's a lot more going on. So let me just show you how to build that. So this top gate here is an AND gate, and so let's go to our gate section, and we'll pull down an AND gate like that. Okay, and then this one is a Noc Gate. Be careful, there's this thing called a buffer. I'll pull it out. It looks an awful lot like a Noc Gate, but if you notice, the Noc Gate has the little circle in front, whereas the buffer doesn't. Also, the Noc Gate is actually labeled. Okay, so there's a Noc Gate, so we'll put that Noc Gate underneath the AND gate here like that. You can see I have a AND and a NOT, and that one is an OR gate, so we need an OR gate. Where is that? There it is. Okay, and then we need 2 switches. Okay, 2 toggle switches, so we'd pull in a toggle switch and we pull in a toggle switch, and we need 2 outputs, that is 2 light bulbs. Okay, so there's a light bulb for here, and there's a light bulb for there, like that, and then you just join them up, and you have to be careful when you do this. Okay, so take a look. Whoops, take a look. See that toggle switch input A here goes just to the top of the AND gate like that. This input B here, that switch actually goes to both the AND and the Noc Gate. Okay, and you could do that. So what you do is you first attach it to the AND gate like that. Okay, and then you click and drag again, and you attach it to the Noc Gate. Okay, and then the AND gate feeds output A like this, but the AND gate is also fed into the OR gate like that. and the Noc Gate feeds the other lead of the OR gate. And then finally the OR gate is attached to the light bulb like that. Okay, now these two circuits are exactly identical. The reason I did the bottom one is I just wanted to talk you through how you build those circuits using logic.ly by dragging the way I showed you. And just be careful, do it systematically. First put all your components out on the in the page, and then just attach them by clicking and dragging from, like, you know, the toggle switch and so on. So what I'm going to do now is I'm going to delete everything that I don't need here. I think I can I do? Yeah, there we go. Okay. Again, those were two identical circuits. I just wanted to show you how to build them. Now let's read the question again. Okay. So finish this following table. Now what I mean by this table, okay, is, you know, if input A and input B are both 0, what is output A doing? So I could put a question mark there. And what is output B doing? Okay. In other words, if both switch A and switch B are off, okay, the two switches that are labeled input A and input B, if they're both off, what is light bulb A doing? That's output A. And what's light bulb B doing? Okay, so let's take a look. Both switches are off right now. Okay, you can see that both of them have that white border. So both switches are off. And what you discover is that input A is off because it's white. Okay, and input B is on. And so we go back here, we would say, okay, with both switches off, input A is off and input B was on. All right, so let me just walk you through that again. This says set both of the switches to off. Set switch A to off. Switch A is input A. So when I say input A, I mean switch A. Okay, so set the switch labeled input A to off. Set the switch labeled input B to off. What is the light bulb labeled output A, what is it doing? Well, it's off. And what is the light bulb labeled B, output B? What is it doing? It was on. Okay, so we could switch back and take a look. A is off and B is on. Okay, remember blue is on. Okay, now what? Well, there's 4 possibilities, right? So this one says, the next one here, this one right here, says now have switch A off and B on. Okay, so A is off, B is on. Input A is off, input B is on. Okay, so let's switch back here and we're going to say, okay, input A is off and input B is on. All right, does everyone see how I did that? So, you know, again, if you look at the table, under input A it had 0 and under input B it had 1. So that means this switch is off, this switch is on. And now what are the light bulbs doing? Well, they are both off, aren't they? Okay, and so back here you would say, okay, when the switches are in this configuration, that's off, and this one is also off. Okay, so that takes care of the of that one. What about this one? This was, well, this row says now have input A on and B off. Okay, so flip the two. You know, A is on, B is off. Okay, let's go back here. All right, and now we're going to do A is on and B is off, like that. All right, and you take a look at the output, and remarkably, it's the same as when they were both off. Okay, so now we have that input A is off and input B is on. Okay, so off, on. So when we switch back here, we're going to say, okay, input A is off and input B is on, like that. Okay, and then finally this last row says what happens when they are both on. Okay, what happens when they are both on? So both switches have to be on. So switch here, okay, and take a look there, and you can see now that input A is on, input B is on, and what are the light bulbs doing? They're both on. Okay, and so let's switch back here and we can say, all right, input A is on and input B is on, like that. Okay, and that completes the table. Let's see if we can like, that's sufficient, but all we did was we kind of just played with, you know, the website and, you know, just turn switches on and off. Let's see if we can reason through why it works the way it does. Okay, because you might have to do some of that kind of reasoning on the test. All right, so I won't make it too hard, but, you know, might as well show it to you now. Okay, so what do I mean by that? So if you take a look at this circuit here, let's see why both light bulbs are on. Okay, let's see why both are on. So switch A is on and switch B is on. Okay, now switch A, what does it do? Switch A feeds into the AND gate, and switch B feeds into the AND gate. So switch A and B, what they're doing is they're feeding two ones into this AND gate. Now what's 1 and 1? Well, 1 and 1 is 1. And so you can see the wire that comes out of the AND gate is a 1. Blue shows a 1. And so when that blue goes to the light bulb there, it turns it on. Okay. Once again, switch A is on, so it feeds a 1 to the AND gate. Switch B is on, so it feeds a 1 into the AND gate. 1 and 1 is 1, so what comes out of the AND gate is a 1. And that 1 means that light bulb A is turned on. Okay. But there's more. Switch B also feeds into the Noc gate. Okay, that means that that 1 that goes into the Noc gate turns into a 0, and you can see that a blue is going into the Noc gate. That is a 1's going into the Noc gate, and white is coming out like that. But white is 0. Okay, and so there's a 0 being fed into the OR gate, but there's something else being fed into the OR gate, and that's the 1 coming out of the AND gate. Okay, so you've got a 0 and the 1 going into the OR gate. 0 or 1 is equal to 1, and that's why the light bulb B is turned on. Okay, and so you can reason it through that way, and what you could do is you can actually put some like a label here. All right, so I mean if you were doing this, you could use pen and paper, but you could say, look at that, that is a 1 right there. Okay, so there's a 1 being fed into that AND gate right there. Okay, and then you could go, you know what, there's another 1 being fed into the AND gate right there. Okay, this top one here is coming from the switch A. This bottom one is coming from switch B. Okay, and so if you feed a 1 and a 1 into the AND gate, what comes out? Well, what comes out is a 1, like that. Now where does that 1 go? It branches. It goes into the light bulb, which turns it on, but that 1 also travels down here and goes into the OR gate. Okay, so one of the things that goes into that OR gate right there is a 1. But there's the other switch too, and switch B, it feeds into this Noc gate. It feeds a 1 into the Noc gate. Okay, so you can see that 1. Remember, where there's blue, there's a 1. And then what comes out of the Noc gate? What comes out of the Noc gate is a 0, like that. Okay, and so now 0 is coming out of the Noc gate. A 0 is being fed into the OR gate. We have 1 or 0. 1 or 0 is equal to 1, like that. Okay, and there you go. That's how you reason through these circuits. Okay, now you won't have to reason through anything this complicated, but you might have to reason through these circuits. Okay, and also it's a good check, to make sure that you've done things right. Okay, so all right, there's that one, and we've answered that question. Let me switch back to this. Okay, because we've completed the table. All right, like that. So when both switches, just to summarize, when both switches are off, like that, then what winds up happening is A is off, light bulb A is off, and light bulb B is on. Okay, when switch A is off and switch B is on, both light bulbs are off. When switch A is on and switch B is off, then light bulb A is off and light bulb B is on. And when both switches are on, both lights are on. Okay, so there's this kind of strange logic that you have. All right. And all right, let's continue with the next one. So the next one is pretty involved because there's 8 possibilities. Okay, so repeat, but with this circuit called B. Let me show you circuit B, and you'll see why you have 8 possibilities. Okay, so here's circuit B. I won't rebuild it, but circuit B, it has 3 switches. Okay, and whenever you have 3, that actually leads to 8 possibilities. Okay, and you say, why are there 8 possibilities? Well, because the first switch can be in one of 2 possible states. Okay, independently, the second switch can be in one of 2 possible states, and the third switch can be in any one of 2 possible states. So there are 2 possibilities for the first switch, 2 times 2 for the second, times 2 for the third, 2 times 2 times 2 is equal to 8. Okay, and that's why when you go back to this table here that I have highlighted, there's actually 8 possibilities. Okay, I'm not going to go through all 8 possibilities because I don't think it's necessary. You'll see how that works. I'll just select a few of them and we'll see what happens. Okay, but basically let's just look at the circuit first, and then I'll just choose a few of these possibilities and we'll see what the answer is. Okay, otherwise it gets too tedious to go through all of them. Okay, so let's take a look at what this circuit looks like. Okay, let me see if I can make it just a little bit bigger. Oh, maybe too big. Okay, that's let me see here, move it around a little bit, make it just a little bit bigger. No, it's hard to make it. What does that look like? Okay, that's good, that's perfect. Okay, so you can see it a little bit better. Okay, so there are the 3 switches: input A here, input B, and input C. And then it goes through these cascade of gates. And actually what I did was I chose 3, I just chose 3 exclusive OR gates. Okay, and there's only 2 outputs there like that. Okay, light bulb A. Oh, I called them input. That should be called actually output. Okay, that's actually output, because the light bulbs are outputs and the switches are inputs. Okay, you set the switches and the light bulbs respond. Okay, that's why they're outputs. The light bulbs are outputs. Okay, so let's go back and take a look at my chart here. Let's just pick where they're all off. Okay, so you say, all right, so I'm going to turn off all 3 switches. Okay, what's light bulb A and B doing? All right, and let's see. Okay, so we go back here, and you can see that with all 3 switches off, both light bulbs are off. That was easy. So all 3 switches off, output A is off, and output B is off. Okay, let's do this one right here. Okay, the next one. All right, so what does that say? That says input A is off, input B is off, and input C is on. Okay, so let's switch to this. So input A is off, input B is off, and input C is on. Okay, so there we go. Off, off, on. All right, and now if you take a look at the answer, which are the light bulbs, A is off and B is on. Okay, so just remember that A is off, B is on. So if you go over here, you're going to say, okay, what is A doing? A is off and B is on. All right, let's do the next one. And I got the next one wrong. That should be a 1, a 1, and that should be a 1 and a 1 there like that. Okay, now we've got all 8 possibilities. Okay, so we did this one. Let's do this one. This one says A is on, A is off, B is on, and C is off. Okay, so off, on, off. Okay, only B is on. Okay, on, off, off, on, off. Switch over here. Okay, and so off, on, off, off, on, off. And if you take a look at the output, this time A is on and B is off. Okay, so over here, if we go to put the answer in, this time A was on and B was off. Okay, let's do a couple more. Okay, so what does this say? This says that A is off and B and C are on. Okay, so it's going to be off, on, on. All right, and let's switch here. Let's do this. Off, on, on. And so if we got off, on, so 0, 1, 1 for our inputs, the outputs are both on. Both light bulbs are going to be on. Okay, so put that into the table here. So A was off, B was on, C was on. Let's just check again. A was off, B was on, C was on. Okay, and what we get are that both light bulbs are on. And so in our table here, we will put output A is on and output B is on. Okay, do you see how this is working? All right. Okay, what about that one? That one says that A is on and B and C are off. Okay, so on, off, off. Okay, switch over here. And so we're going to do on, off, off. So 1, 0, 0. And if you take a look at the output is both light bulbs are on. Okay, so if you go back to the table and you say, okay, under when when I had A on, B off, and C off, what do you get? You get that both A and B are on. All right. And I don't know, just maybe one more. It's not that much. Maybe I'll finish them off. It's not that much, okay? So this one says on, off, on, okay? And so we go back here, on, off, on, and what you get is that, so 1, 0, 1, on, off, on, you get that A is on and B is off. So A is on and B is off. I'll finish them off quickly, okay? And so the next one says A is on, B is on, and C is off. So only C is off. What are the light bulbs going to do? So only C is off here, on, off. And now we have that light bulb B is on, but A is off, okay? So it's going to be A off, B on. All right. A off and B on. All right. And then finally, so I guess I will finish him, but this says all three switches are on. Okay, A is on, A is on here, B is on, and C is on. Okay, so we go back here, turn on all three switches, and what do you get? Both light bulbs are off. Okay, so back here, all right, A is off and B is off. Okay, so there you go. Just some made-up circuits to play with, okay? And before we leave this, let's just trace through the logic for one of them and see what happens, okay? So just like we traced through the logic for the previous one, let's trace through the logic for this particular configuration right here. So, you know, A and B are on, but C is off, and you might ask the question, why is light bulb A off? And why is light bulb B on? Okay, can we work that one through? Okay, so I'm going to put some labels in here. So you could see here that switch A is feeding a 1 into the top exclusive OR gate, okay? And you say, well, why? Well, switch A is on, input A is on, okay? So that on, see that blue there? It just travels, that blue travels along the wire, that 1 travels along the wire, and it gets into the exclusive OR there like that, okay? Now B is also on, okay? So that's another 1. And so B feeds a 1, and that 1 gets fed into the top exclusive OR gate there like that, okay? So that top exclusive OR gate is being fed 2 1s. What comes out of an exclusive OR when 2 1s are fed in? 1 exclusive OR 1 is equal to 0. Okay, and so what comes out is a 0. Remember, that's the unique one for the exclusive OR. Okay, oops, like that. Okay, so the 0 gets fed out there like that. Okay. Now, where does that 0 go? It goes a couple of places, okay? One place that it goes, because it branches right here, okay? See how the output of the exclusive OR branches? That 0 follows the one branch, and it goes to the light, whoops, okay? And it's fed into the light, and so that light is off, okay? And then there's another 0, okay, that comes out, not another 0, but the 0, like I said, it branches, okay, and that 0 also travels along the second branch here, and that second branch gets fed into the second exclusive OR. Okay, now we're not quite done yet because we looked at what happened here, but let's take a look at what's happening for the exclusive OR on the bottom here. So we have switch B, which is feeding a 1, but that 1 not only goes to the top exclusive OR, okay, right here, okay, but that 1 also goes to this bottom exclusive OR there like that. Okay? And finally, switch C, that one is producing a 0. And you go, okay, where does that 0 go? That 0 also travels along this white wire here. That's a 0. White is 0. And it gets fed into the bottom exclusive OR gate there like that. Okay? And so now what happens when you feed a 1 and 0 into an exclusive OR? 1 exclusive OR 0 is 1. And so what comes out is a 1, and you can see it there as blue. Okay, so what's coming out of this bottom exclusive OR gate is a 1. And what happens is that 1 travels, it travels, it travels, it travels, and it's fed into our last and third exclusive OR right there. And then you say, okay, well, what do you get when you feed a 0 and a 1 into an exclusive OR? And 0 exclusive OR 1 is 1. And so what comes out of that is a 1, like that. Okay? And where does that 1 go? It travels, and you can see the blue wire there. It travels, it travels, it travels, it travels. Whoops. Oh, okay. Hold on. There we go. It travels, it travels, it travels, and it finally travels to the light bulb, and so that light bulb is on. Okay? Now, I mean, there's 8 possibilities to trace out, but that's good enough. Okay? So what I showed you there is, just why the light bulbs are doing what they're doing. Okay? These gates are acting, according to the logic that they're supposed to act on. For this particular circuit, they're just exclusive OR. So these 3 gates are doing exclusive OR logic. And if you just trace through where the 1s are going and where the 0s are going, you could figure out which light bulb is on and which light bulb is off. Okay, so I hope this answers the question of the kinds of questions that I would ask on a test. The 2-bit adder is pretty easy. Okay, you should know the 2-bit adder. The 3-bit adder is a little bit more complicated because it actually involves 5 gates. Okay, I don't think I would go that far. I think I would like to stick to about 3 gates, like this one, something like that. Okay, but you should be able to do 3 gates or 4 gates is maybe pushing it, but at least 3 gates, and be able to trace through the logic. If you can't quite trace through the logic, you could always use logic.ly as well to help you. Okay, but like on a test, if you know how to trace through the logic, usually you could just look at the circuit and figure it out pretty quickly. But if you wanted to, check yourself, then you could also check yourself using logic.ly. Okay, so that's it for our little tutorial, and bye-bye.